Okay, Assalamualaikum dan salam sejahtera to all my MEC101 students. I hope all of you are in good health after we have 1 week of mid-sem break. During our COVID pandemic here, make sure you take care of yourself. If you have the problem with your health, uh, get help as soon as possible. Okay, so for this video, we will continue with our learning for the MEC 101. Okay, we are going to learn about the chapter 5, dimensions and units. Okay, the objective uh, is to state the basic quantities and their respective SI unit, to state derived quantities and their respective SI unit, and so on. Okay, I will skip this objective, you have to read by your own. Okay, so in this chapter we have 7 sub chapter. Okay, so for this video, I will cover the 5.1, 5.2, 5.3, 5.4, 5.5, and 5.6. Okay, and then for the 5.7, I will separate it in the another video. Okay, so let's get started. I think every one of you have already learned about the SI unit in the physics subject during your Form 4, Form 5 syllabus. Okay, so I will just go a little bit faster about the introductions. Okay, the SI unit stands for the English terms of International System of Units, because SI system international, I don't know how to pronounce it. It is in the French language. So if we translate into the English, we have the terms of the SI units is International System of Units. Okay, so in the SI unit we have physical quantities. Okay, the physical quantities can be divided into 2 types. Okay, we have the basic one, we call it basic quantity, or sometimes we call it fundamental quantity. And then using the basic or fundamental quantities, we derive into the another form. That's what we call the derived quantity. Okay, so basically for the basic quantity, or in this slide we call it fundamental physical quantity, there are only seven basic quantity. So this is I think you have learned in this Form 4 syllabus, because I still remember this one. I learned in my school in the Form 4. Okay, so mass, length, time, temperature, electric current, amount of substance, and luminous intensity. These are the only basic quantity in the SI system, SI unit. Okay, so for the mass, we have kilogram unit. Length, we have the meter. Time, we have the seconds. Temperature, we have Kelvin. Okay, electric current, we have ampere, and amount of substance, we have mole. Okay, and then luminous intensity is we use the candela unit. Okay, so this is the symbol. Okay, symbol of the unit. Okay, I will go faster. Okay, this is the examples of derived physical quantity. Okay, these are the combinations of the basic quantity. Okay, example are area, volume, velocity, acceleration, force, momentum, and work. So its units will be based on the basic unit here. So as example here, we have the meter square, means that length times length. Okay, so for the volume here we have the length times length times length, because this index of the unit represent for the how many times you multiply that basic unit. Okay, so this I think these are very familiar for you. You already learn most of them in your SPM syllabus. Okay, so this is the example of the derived quantity. Okay, velocity, as we know that velocity is equal to the displacement over time. So this displacement unit is the meter, and the unit for the time is the second. So we will have the meter per second. So you can write down the unit as like this: meter as -1. Okay, meter second to the power of -1. Okay, that's it. So these are the example of the derived quantity that you normally found it in the physics during your SPM syllabus. So for our engineering courses, the derived and the basic quantities are very important. Okay, so you will face these units in your for a whole life. I think for the whole life until you die, because you are going to work as an engineer maybe. So for sure in the engineering fields, the SI unit will be your everyday use of the knowledge. Okay, so okay, prefix here are used to represent larger or smaller value. Okay, sometimes we can use the prefix to make it the term become simpler. Okay, let's say I think it is more difficult if you want to write down the 10 to the power of -12. Okay, so we just replace this one, the mathematical form here, using the word here pico. Okay, so this is what we call the prefix. Okay, so the symbol, or we call the abbreviations for the pico, is P, nano, and micro here, like this. This is the Greek Latin words. Okay, milli, M, centi, C, deci, D, kilo, K, mega, M, giga, G, T, tera, and so on. So there are many others prefixes that are not shown in these examples. So I think these prefix you must remember. Okay, because sometimes in the questions in your future courses in our engineering program, you will face the prefix a lot more, and then if you do not remember the power of that prefix, it will become the problems for you to answer the questions. Okay, let's say in the questions tell you that the okay, sorry, what happened? Sorry, technical problem with my tablet. Okay, let's say we have micrometer. So if you do not remember the power of the micro, that this is the represent I think the power of 10 to the power of minus 6 meter. So make sure you have to remember all of this, because these are very common prefix that are going to be used in the engineering syllabus or engineering field. Okay, so this is the history of the SI unit. Okay, the name was set in 1960 and so on. Okay. Okay, so let's go to the fundamental. The definitions of the length. 1 meter is equal to the distance traveled by light in a vacuum during 1 to over 299792458 seconds. So don't worry about the definitions. You just have to remember that the length is the fixed distance, okay, that where is the light travel to a certain conditions. Okay, so for every definition of the SI basic units, it will be fixed, maybe not completely fixed, but almost fixed forever. So the standards for every basic unit will become constant for the whole of our applications of our engineering fields and the scientific words. Okay, so don't worry about the definitions. You just have to know that every basic unit is defined by a certain fixed conditions. Okay, let's say here the time is 1 second, blah 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 blah. Okay, I also do not remember all of this, but I know that 1 second, my 1 second is also equal to your 1 second. So we will not vary the value of the 1 second. Okay, so that is the important things about the units. We have to fix a standards for every SI units, so that our scientific field will become the more accurate. I don't think the more accurate will become a large accurate compared if we do not have the standards for every SI units. Okay, so the temperature, blah blah blah, you can read by your own, and mass here, blah 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 blah. Okay, so this is the supplementary units that are no longer be used. Okay, you can see here. And then derived units, as I mentioned earlier, the derived units is a combinations of the basic units. Okay, so I can skip a few slides here. Okay, so we go to the rules of units. Okay, engineers should understand thoroughly and apply properly the new system. To apply, we have to follow the rule: unit symbol and names, multiplications and divisions, numbers, calculating with SI units. Okay, so these are the rules. That unit symbol written in lower letters or lowercase letters, so the unit must be in the lowercase. Exception the ampere, Kelvin, Hertz, Pascal, and C here. I don't think this is the Celsius. Okay, so the symbol name after an individual are capitalized. Okay, let's say the Newton, N, so this is the capital letter. Also apply to this A, ampere. Ampere is also the name of the scientist. Kelvin also a name for the scientist, and also Hertz, Pascal. Okay, so symbol should be used to represent units, and S is never added to the symbol to detonate plural. So it's not the same as in the English grammar plural, where we have the multiple numbers, we have to put the S. No. So in the units, we never add S here. Okay, so use space between numerical and unit symbol. Okay, so you must be remembered that between the numbers and the units, it must be a gap space. Okay, exception for the degree, minutes and seconds for angle and for degree Celsius. Okay, the symbol should not be used in preferences to the unit name. 10 meter not 10 meters, or 10 meters not 10 meter. Okay, quantity is defined by several units which are multiples or separated by a dot here. Let's say, so kilogram, you must put the dot, meter per second. Okay, so during where the multiplications operations in the unit, you must put the dots. Okay, this is the rules that is rarely used in our daily we call daily habits, because sometimes during our tests or your assignments, okay, let's say I also use the kilogram, meter per second like this. Okay, but for the proper or formal way to write the units, we have to put the dot here. Okay, so let's try to apply or to implement this habit, this rule. Make sure we put the dot between the multiplications operations between the unit here. Okay, physical constant with several digits on either side should be written with space between 3 digits rather than a comma. Okay, okay, let's say if you in the finance industry, when we have to put 1 million ringgit. Okay, so the culture in the finance industry, we will put here comma, right, and then dot cent. Okay, so if we implement this rule for the scientific field, like our engineering field, so we cannot put the comma here. This is wrong, this is wrong. So what the rule wants you to do is you left the space here, okay, between 3 digits. Okay, so in calculations, represent numbers in terms of their base or derived units by converting all prefix to power of tens. Okay, it's recommended lah you to convert all the numbers that the power of tens. You have to use the prefix to convert the numbers to the power of tens. Okay, so the another rules of units. Okay, this is what I want you to focus. How to write or to convert the units. Okay, let's start it with the example in the slides. Okay, let's say here for the A, 150 meganewtons times 2 kilonewtons. Okay, make sure this is the very basic. Make sure you already understand and know how to solve this problem. Okay, 150 meganewtons. So you can, okay, I use the color here. Okay, 150 mega. Okay, so mega, you use the 10 to the power of 6. That's why earlier I mentioned that you must remember the power of the prefix here. Okay, and then you multiply with, this is the Newton, you multiply with 2 kilo. Kilo means that 10 to the power of 3 Newton. So the mathematical operations here is very straightforward. You just multiply 150 times 2 and then you get 300. 10 to the power 6. Okay, when you multiply with this 10 to the power of 3, you will get 10 to the power of 9. And then Newton times Newton, you will get Newton square. Okay, so what is the prefix for the 10 to the power of 9? Okay, so you have to remember that after mega there will be giga. Giga 10 to the power of 9. So there will be 300 giga Newton square. Okay, very straightforward and easy peasy. Okay, so here okay, the solutions here is wrong because here they put the milli, but here in the question itself shows that mega. So okay, let's say if this is the small m, means that it is milli, so this is the answer. If the question here means that capital M means for the mega, so my answer is the correct ones. Okay, so let's say I will put another alternative to this. Let's say it is the millinewton. So 150 times to the 10 to the power of minus 3 means that it is millinewtons, times with the 2 kilo 10 to the power of 3 newtons. So still 300 minus 3 plus 3, so it means that 10 to the power of, okay, 3 minus 3 plus 3, so you will get 0, right? So that will be Newton square. Okay, 10 to the power of 0 means that 1. Okay, you already learned in this one in your additional mathematics, matematik tambah kan, SPM. Okay, so the answer will be 300 Newton square. This solution if the question means that small m should be here, not the capital M. So small m, small case m means that the milli. So this is the answer. If the question itself means for the mega here, so this is the answer. But the solution here, okay, is very different because the question is not the same as the solution here. Okay, this is 150 millinewton times 6 giganewton. We have 150 meganewton times 2 kilonewtons. Okay, so make sure you try and make sure you know that if you have difficulty to solve this problem, the unit, this is the simpler form of mathematical operations, please let me know. Okay, if you still malu-malu, okay, I will okay lah, boleh personal message saya, tapi saya lagi recommend you to ask me the questions in the main WhatsApp group, because if I answer your problem and then every one of you can know the answers. Okay, jadi semua dapat manfaat lah. Saya recommend macam tu. Tapi kalau terlalu malu sangat, bolehlah personal message saya. Okay, for B 2 meganewtons divide by 900 gigakilogram. Okay, so this is A. Okay, I put here B. So 2 mega means that 10 to the power of 6 newtons. Okay, over 900 giga means that 10 to the power of what we call giga 9 kilogram. Okay, so this will be 2 over 900 times 10 minus 10 to the power of 6. Okay, when you divide, it will be the minus here, minus 9. Okay, Newton per kg, so it will be the Newton kg minus 1. Okay, so it will be you have to use the calculator. I just let it be 2 over 900 here. Okay, 6 minus 9 will be 10 to the power of minus 3 Newton kg minus. Okay, this is the answer. Okay, same thing happens here. The question here is different to the question in these solutions. Okay, so never mind, you can refer the solutions, but it is not the answer for these questions. Okay, so okay, let's try this one first. Convert to SI unit, 400 millimeter times 0.6 mega Newton square. Okay, so you will get 400 milli 10 to the power of minus 3 meter times, okay, this one is square, so 0.6 also squared, mega here also squared. So what is the power base of the mega? It is 10 to the power of 6 times 2 square here, so you have to multiply with 2. So Newton is the unit, so let it be. So Newton is Newton square. Okay, 400 times 10 to the power of 3. Okay, unit here I will put it at the end of this line. So here times 0.6 square times 10 to the power of 12 meter Newton square. Okay, so the whole number here 400, you have to multiply with 0.6 square. Just use your calculator, you will get 144. Okay, 10 to the power of minus 3, when you multiply with 10 to the power of 12, it will be minus 3 plus 12. So you will get 9, right? Meter Newton square. So if you change this into prefix, and then you will get 144. 9 10 to the power of 9 is giga. Okay, if you do not remember here, just refer back to the prefix list in this slide. Where is that? Okay, here 9 is giga, right? So the symbol of the giga is G, capital G. So I replace 10 to the power of 9 with the giga G here, so we will get here, this is the final answer. Okay, so I put extra 2 examples how to manipulate the units during your problem solving. Okay, let's say we try this problem first. Okay, a 3 kilogram plastic tank that has a volume of 0.2 meter cube is filled with the liquid water. Assuming the density of water is 10,000 kilogram per meter cube, determine the weight of the combined system. Okay, this one, to solve this problem, is not does not need a very high knowledge of the engineering field, engineering knowledge. It just use the manipulation of the units and the equations. Why? Because the basic units that you know, this one is the mass, right? Kilogram. The unit here, kilogram, means that it is mass. So how to solve it? Just put it the symbol. This one is mass. That has a volume of 0.2 meter cube. Okay, I see here the unit is meter cube, so I know this is the volume, even if the question itself doesn't state that it is volume. Okay, let's say the question doesn't put the volume word here. I still know that 0.2 is the volume. Why? Because based on its units, meter cube, I know this one is the unit for the volume. So I put here V. Is filled with the liquid water. Okay, assuming the density of water is 10,000 kilogram per meter cube. Okay, this one is the unit. Okay, so that's why the unit here shows that this value 1000 is the density, or is the symbol of density, like this. Okay, so determine the weight of the combined system. So now I list down the value I know from the questions. So I have the mass of the tank. I put M tank. It is 3 kilogram. Okay, I know the volume in the tank. Volume is 0.2 meter cube. Okay, and also I know the density of the water is 1000 kilogram per meter cube. Okay, and then what is the questions want you to find the value? The weight of the combined system means that mass of what is not an weight is the mass time of the gravity, right? Okay, weight equal to mass time gravity, mg. Okay, but here we have to know the mass of water before we continue with the calculations to find the weight here. Okay, so you see here how to get the mass of water. The density here means the density for the water. Okay, and the volume here also means that the volume for the water in that tank. Okay, how to manipulate the units or the equations? I know the mass of water must be the unit in the kilogram. Okay, I have the value of density, the unit here. Okay, we have the kilogram. So now we must manipulate the value from the density to find the mass of water. Okay, let's say I do not remember the equations of the density, but I can rewrite the equations formula for the density by only looking at the units here. So the density, if I do not remember, kilogram, what is the kilogram? Mass, right? Meter cube, what is the meter cube? Volume. So I know density is equal to mass over volume. And then now my problem is to find the mass of water. So now I can manipulate these equations. So the mass can be found by density times volume. Okay, so what is the value of volume? What is the value of density? It is 1000. What is the value of volume? It is already given here, 0.2. Okay, still I don't put the unit, and then I must put the unit at the end of this term. Okay, 1000 is the kilogram per meter cube, right? This is the density. The unit here is given, and 0.2, the unit of the meter cube. Okay, so let's solve it. 1000 times 0.2, you will get 200, maybe, right? 200. Okay. Okay, now the kilogram per meter cube multiply with the meter cube, so this one will be eliminated, cancel off. So the unit remains here is kilogram. So is it correct, the unit for the mass? Yes, it is correct. So this is the mass of water. Simpler, right? So in engineering, you are going to face a lot of the problems that must be only solved if you master in the unit conversion and the formula manipulations like this. This is just the simple questions here, and I hope you will see the importance how to manipulate the units and the manipulations of the formula based on the units like this. Okay, so I will let you do these questions. So if any one of you do not answer this question, so that mean that that person does not watch my video. Okay, I will not put this question in the Google Classroom. I just put here in the video, but you must show me your calculations, okay, to get the answers here. So this is the homework. You have to write your solutions, and you take picture the solutions, okay, and put it in the Google Drive and share that link in the Google Classroom. I will put a section for this homework. Okay, so make sure you do these questions here. I repeat, do these questions. If not, so means that you are not watching my video. Okay, I repeat, I will give you a week times to solve this problem. It is just a simple questions here. Okay, so let's go to the US customary system, USCS. Okay, before that, I will show you this map. What do you think about this map? Okay, what about this map? There are only 1, 2, 3 countries. There is in the red color. Okay, these 3 countries are the only countries that are still use the imperial units, or what we call now is the USCS, US customary system. Customary means custom kan, special. Okay, sebab this is the base on the imperial units from the UK, but the UK itself is implementing the SI unit. Okay, so negara-negara ni keras kepala. Bekas, sebab apa? Okay, sebab US the biggest economy country in the world, the most powerful army in the world. Jadi dia keras kepala ikut suka hati dia tak nak tukar. So kita negara-negara lain still have to learn these units, customary units. But this is very inferior compared to SI unit. SI unit lagi superior, lagi accurate, lagi terbaik untuk scientific terms. Okay, so dekat US, many segment of the US industry complex regularly use the system. Okay, there are two systems of units other than SI that are commonly used in the United System, US Customary System, Engineering System. Okay, kalau awak try Google nanti, raja-raja Google, NASA dulu first dia pakai USCS. Lepas tu bila berlaku kemalangan dekat dia punya roket meletup, so dia dapat tahu, dia detect sebenarnya problem dia dekat unit conversions. Okay, bila dia convert unit dari USCS kepada SI, daripada SI ke USCS, accuracy dia akan hilang, akan lari. So dalam SI unit, dalam space industry, benda tu sangat penting lah, accuracy. So berlaku kemalangan lah. Okay, that's why now the NASA is using the SI units for their works, but for the other industrial works macam construction dekat US still use the US customary system. Okay, contoh-contoh USCS ni adalah foot, second, pound, kan? Okay, kelajuan pun kalau kita panggil biasa, kalau kelajuan kereta kita guna kilometer per hour, kan? Okay, betul. Tapi diorang masih lagi guna mph, means that miles per hour. Okay, jadi benda-benda ni masih lagi budaya digunakan kat sana. Okay, so awak kena belajar jugalah macam mana nak convert unit. Okay, so let's say, okay, this more dimensions here. Okay, sikit je lagi nak habis untuk video ni. So you have to know how to convert from the imperial units to the SI units, and vice versa lah, daripada SI kepada imperial, and from the imperial to USI. Okay, let's say 1 meter equal to 3.28 feet. Okay, ni I approximately lebih kurang lah. Okay, tapi nak tahu accuracy of the unit conversion here, you can use the other calculator in the internet. Banyak sangat dekat internet, Google je contoh lah, unit converter lah. Dekat Google sendiri pun ada ni. Nak buka. Okay, so 1 mile sama dengan 1.609, atau kalau dalam kilometer 1.69 macam tu lah. Okay, kalau feet, okay, foot 1 meter equal to 3.28084. okay, kan? Saya hanya guna 328. Sebab tu bila berlaku unit conversion mana tadi, akan hilanglah accuracy dia. Sebab tu kalau dalam scientific bidang scientific, termasuklah engineering, kita kena pakai SI unit. Okay, tapi tak nak sebab US, kena juga belajar imperial unit ni. Okay, so nak tukar, ada contoh, saya ada 4.28 meter to feet. How many? Okay, macam mana nak guna? Okay, 1 meter equal to 3.28. Okay, let's say here. So, cara dia. Okay, letak kat sini 4.28 meter. Sekarang nak tukar kepada feet. Tulis dulu siap-siap kat sini feet. Okay, Jadi awak kena fikir, saya kena wujudkan meter dekat sini, kat sini. Sebab sini ada meter. So, saya letaklah meter kat sini. Okey, 1 meter saya letak sama dengan per feet. Contoh. 1 meter sama dengan, okey, ni dia. Yang ni constant, nilai. Yang ni memang kena ingat. 1 meter sama dengan 3.28 feet. Okey, dalam segi mathematical form ya, feet darat dengan feet akan cancel kan? Okey, tapi mana nilai 4.28 ni? Kena letak sini. 4.28. So, jadilah bila cancel, awak akan dapat balik nilai kat sini. Okey. Okey, tapi kita nak dalam bentuk feet. So, feet ni tak boleh cancel. Betul? Feet tak boleh cancel. Feet ni kena wujud. Jadi, awak kena make sure feet ni tak di cancel. So, kena buatlah 3.28 feet sama dengan dalam meter 1. So, awak kena darab dengan meter nak cancel. So, nilai ni masukkan. Macam tu. Barulah tinggal unit sini. Feet, meter dah cancel. So, jadilah nilai dia 4.28 darab 3.28. Jadi 14.0384 kaki feet. Ni cara convert. Okey, cara nak check. Okey, kita tengok balik dekat Google kita tadi. Berapa? 4.28 kan? Betul eh? 4.28. Okey. Jawapan dia 14.04. Jawapan saya 14.0384. Sebab apa? Accuracy kita dah lari. Sebab saya guna 3.28. Calculator ni guna lagi 3.281 panjang-panjang tadilah. Tapi kat depan dia masih lagi sama 14. Okey. Tu cara nak tukar unit daripada imperial ataupun daripada SI kepada imperial ataupun imperial kepada SI. Okey, awak kena try. Kena cuba try, apa tu, double check dekat calculator lah, internet pun boleh, dalam calculator awak pun boleh. Okay, so ni examples ya, conversion of units. You try. If you still do not understand or have difficulty to understand that unit conversions, let me know. Ask me again. I will give you more questions and you have to do more practice. Okay, ni tetap kena practice. Tak boleh tengok sekali, okay, tutup buku dah faham. Tak, you have to practice. Okay, when you practicing it, you are going to get the concept or the fundamentals behind the unit conversions. Okay, you look that unit is more on the basic term, but the basic one is the most important thing during before you go deeper into the engineering fields. Okay, so you must have to try the question and the examples here, and then that's it for our video today. Do not forget, make sure you answer these questions. I repeat, you have to answer these questions and put your answers in the Google Drive and share me your links. If any one of you do not put the answer in the Google Drive and do not share your links, I will assume that person is not watching my video. So I will assume that that person is absent. Okay, so in the next video, I think in the next week we will continue with the dimensions here. So that's it for this video. That's it for our lecture session today. I hope you take care of yourself, and do not forget to practice all the conversions unit exercises here. And the important one is to not forget to do my questions here. Okay, once again, take care, study hard, study smart. Assalamualaikum, jaga diri, kita jaga kita. Salam sejahtera. Okay, bye.